Good day everyone, we hope you are all doing well. We are honored and excited to present you our research study entitled Attendance Monitoring System using Rfid. Before we begin, allow us to briefly introduce ourselves. I am Mary Jane I. Santos and with me are my fellow researchers Rose Anvingua and Ruby Jane Lopez. Together, we conducted this study with the goal of providing a more reliable and automated solution to the common problems faced with manual attendance systems. With that, let us now begin with the introduction of our study. Good day again. In this part of the presentation, I will be introducing our research study entitled Attendance Monitoring System using Rfid. And it aims to develop an automated attendance tracking system for students at Sabela State University, Kawayan Campus. The system we designed makes use of radio frequency identification or RFID technology. With this, students will simply scan their RFID cards at designated entry and exit points within the campus to record their attendance. Each time a card is scanned, the attendance data is automatically captured by the RFID reader and sent through Wi-Fi, which allows the system to update records in real time. This method ensures that attendance is recorded accurately, efficiently, and securely, reducing manual errors and saving time for both students and school personnel. So why is this important? Currently, many schools still use manual logbooks or biometric scanners, which are often slow, inaccurate, and prone to errors. Manual system can result in lost records, long queues, and even cheating. Our proposed system solves these problems by automating the attendance process, improving accuracy, and saving time for both students and professors. So what are the benefits? It reduces human error, avoids data loss, and minimizes the workload for staff. Professors can easily monitor attendance, and students don't have to worry about signing it manually. Objectives of the study. The main objective of our study is to design and develop an RFID attendance monitoring system to help Isabela State University Kawayan Campus manage student attendance more efficiently. To support this goal, we have set the following specific objectives. First, to identify common problems experienced by teachers and advisors when monitoring student attendance manually. Second, to enable the system to detect students with frequent absences so that timely interventions can be made when necessary. Third, to evaluate the effectiveness of the system based on 5 key criteria. We have functional suitability. Does the system meet the needs of its users? We have reliability. Is it consistent and free from errors? We have performance efficiency. Does it operate quickly and smoothly under different conditions? We have usability. Is it user-friendly and easy to navigate? And we have the security. Is the attendance data well protected and access properly controlled? To our user evaluation, to assess the quality and effectiveness of our system, we use a software user evaluation rating form. This form allowed users to rate various aspects of the system using a scale from strongly disagree to strongly agree. The key areas evaluated include usability, how easy and user-friendly the system is. We have UI design, the clarity and appeal of the interface. We have functionality, whether the system performs its intended task. We have performance, the speed and responsiveness of the system. We have compatibility, how well the system works across different devices. And we have the last one, the security, the protection, and control of data access. Overview of the methodology. In this part of the presentation, I will provide an overview of the methodology we use to develop and analyze our RFID attendance monitoring system. First, we begin with the research design. Our study follows a quantitative research design which allowed us to collect measurable data and evaluate the system based on specific performance indicators. Next is the software development methodology. We adopted the waterfall model which follows a step-by-step process from planning and design to development, testing, and evaluation. For hardware and software requirements, we utilize components such as an RFID reader, RFID tags, a Wi-Fi module, and Arduino-based hardware along with the software tools like Arduino IDE and a web-based interface for managing records. Moving on to system architecture, the system is designed to capture RFID scan, send data wirelessly to a database, and display real-time attendance record through a user interface accessible to authorized personnel. Finally, for data collection and analysis, we gathered feedback using evaluation forms and conducted tests to measure the system's performance based on key criteria such as usability, reliability, and security.
Research design. For this study, we applied a quantitative research design. This approach allowed us to collect and analyze numerical data related to student attendance both before and after the implementation of our RFID-based attendance monitoring system. By using quantitative methods, we were able to objectively measure and systems' effectiveness and impact. The main focus areas of our research include attendance tracking efficiency, to see if the system improves how attendance is recorded. System usability, to determine how easy and practical the system is for users. And user satisfaction is to evaluate how satisfied the users are with the system's performance and features. Software development methodology. For the development of our RFID attendance monitoring system, we used the rapid application developed of RAD model. This approach emphasizes speed and flexibility, allowing us to quickly build and refine the system based on continuous user feedback. The process started with analysis and quick design, where we gathered the basic requirements and created an initial system design based on user needs. Next was the prototyping cycle. We developed working prototypes of the system and presented them to users for feedback. This helped us identify issues early and make necessary adjustments. Then came the testing phase, where we evaluate the system's performance, fixed bugs, and made improvements to ensure it met the desired standards. Finally, the implementation phase involved deploying the system for actual use, allowing us to observe its performance in a real-world environment. Using the RAD model helped us deliver a functional and user-centered system in a shorter development time. Hardware requirements. In this slide, I will present the hardware requirements needed to run and support our RFID attendance monitoring system. We have outlined both minimum and recommended specifications. For the CPU, the minimum requirement is an Intel Core i3, while we recommend using an i5 or higher for better performance. In terms of RAM, the system can run on 4GB, but 8GB is recommended for smoother multitasking and responsiveness. For storage, a 256GB HDD is sufficient, but using a 512GB SSID is ideal for faster data access and system performance. Lastly, the RFID reader can function with a standard model, but we suggest using an advanced reader for faster scanning and improved accuracy. Software requirements. Now let us move on to the software requirements for our RFID attendance monitoring system. We have identified both minimum and recommended software tools and platforms to ensure smooth development and operation. For the operating system, the system can run on Windows 10 as minimum requirement, but we recommend Windows 11 or Linux for better stability and performance. In terms of the programming language, the basic setup can use either Python or Java. However, we recommend using Python with the Django framework for faster web development and better backend management. For the database, MySQL or PostgreSQL can be used as the minimum standard, but we recommend Firebase for MySQL for easier integration, real-time syncing, and data scalability. Use case diagram of the system. This slide represents the use case diagram of our RFID attendance monitoring system, which shows the key actors and their interactions with the system. First, we have the student. Their main role is to register attendance by tapping their RFID card at a designated reader. Next is the lecturer, who is responsible for opening class session, monitoring attendance in real time, and submitting attendance reports. The administrators has the task of verifying attendance records and exporting reports for documentation and analysis. Lastly, we have the system administrator, who plays a crucial role in managing user roles, controlling access, and maintaining overall system security. System architecture. This slide illustrates the system architecture of our RFID attendance monitoring system, highlighting the major components and how they work together. First, we have the RFID tag and reader. Students tap their RFID cards and the reader captures the unique ID. Next is the processing unit, which verifies the RFID ID and updates the attendance record in real time. The data is then sent to the database server, where all the students' logs are securely stored and managed. Users interact with the system through a web or desktop application, which provides a user-friendly interface for checking records, opening sessions, and viewing reports. The network module is responsible for transferring data between the RFID reader, processing unit, and the database, ensuring fast and secure communication. Finally, the system includes a report generation feature, which allows users to generate and export attendance reports and monitoring and documentation. Respondents of the study. For this study, we gathered feedback from a diverse group of respondents to ensure a well-rounded evaluation of system. Our target respondents were divided into three groups. Students, who made up 50% of the respondents, as they are the primary users of the RFID system for attendance logging. Faculty members comprising 30% who interact with the system by opening session and submitting reports. The administrators, accounting for 20% who are responsible for verifying and managing attendance data. The purpose of selecting this mix of respondents was to ensure comprehensive feedback from all user types, of covering everyday users, system operators, and supervisors. Data gathering procedures. To ensure the accuracy and reliability of our research, we followed a structured approach in gathering data for the study. The first step was to seek permission and obtain consent from the participants, including students, faculty, and administrators. This ensured ethical compliance and voluntary participation. Next, we distributed questionnaires and conducted interviews to gather both quantitative and qualitative feedback about the system. Afterward, we collected and validated the data, checking for completeness and consistency to ensure the results would be reliable. Finally, the gathered data was encoded and organized for analysis, allowing us to draw meaningful conclusions regarding the system's performance and user satisfaction.
Data analysis. For the data analysis, we use the weighted mean method. This method involves multiplying the frequency of each response by each corresponding score and then dividing by the total number of respondents. This calculation helps us quantify effectiveness and user satisfaction of the RFID system. We also use a Likert scale to interpret the result, which provided clear insight into user attitude. Likert scale interpretation. This table is used to interpret the average score weighted means from survey responses, typically on a 1 to 5 scale. How it works. After collecting responses using a Likert scale, stronger disagree to stronger agree. You calculate the weighted mean for each item. If the score is between 4.20 and 5.0, the result is interpreted as a very high extent, meaning most respondents strongly agree if the score falls between 3.40 and 4.19, it shows high extent, and so on. This helps quantify perception or satisfaction based on survey feedback. Result and discussion demographic profile. Here we see the demographic profile of the respondent. Most of the participants were students aged between 18 to 23 years, which makes sense since this system is primarily aimed at enhancing student attendance. There was a balanced gender distribution with 60% and male and 40% female responded. This diversity in the demographic samples ensures a wide range of feedback. Effectiveness of RFID-based attendance system. Now let's discuss the result in terms of accuracy. The RFID system is scored by high with a mean of 4.5 and a standard deviation of 0.65. This shows that the system accurately tracks attendance. When it comes to the time efficiency, the system scored 4.6, indicating that they significantly reduced the time spent of attendance recording compared to traditional method. Statistically analysis. In the slide, we look at the statistically analysis. AT test was conducted to confirm the effectiveness of the RFID system with the traditional method. The results show that the RFID system had a mean of 4.56, while the traditional method had a mean of only 3.2. The p-value was less than 0.001, indicating that the difference between the two methods is statistically significant. Summary of findings. To summarize the finding, the RFID system provided to be highly effective in tracking attendance. It not only provided accurate data but also saved significant time compared to the traditional method. Most of the users, including students, faculty, and administrators, expressed satisfaction with the system, confirming its practicality and efficiency.
Conclusion. Now we will be wrapping up the presentation, which covers the conclusion and recommendations of our study on the RFID attendance monitoring system. Let us first review the conclusions drawn from the research. This study focused on the development and implementation of an attendance monitoring system using RFID technology at Isabela State University, Kawayan Campus. The primary goal was to address the inefficiencies and inaccuracies inherent in traditional attendance methods and to improve the overall monitoring process to both students and faculty. From the results of the study, we can conclude that the system proved to be highly effective in improving the accuracy, speed, and reliability of attendance tracking. According to the data analysis, most respondents, both students and faculty, expressed high levels of satisfaction, especially in areas like ease of use and time-saving benefits. The RFID system also resulted in a significant reduction in manual errors and provided real-time data access for administrators, allowing for immediate attendance verification. Ultimately, the research confirmed that the integration of RFID technology into the attendance monitoring system offers substantial benefits to both institutional management and student accountability. It's clear that this approach helps streamline the attendance process and ensures more accurate data collection. Moving on to the recommendations. Based on the findings of the study, here are a few key recommendations to further improve and expand the use of the RFID attendance monitoring system. We have wider implementation. It is recommended that the RFID system be implemented across all departments within the university. This would standardize the attendance monitoring process, ensuring consistency across different programs and departments, ultimately improving overall student tracking. System enhancement. Future upgrades should include SMS or email notifications for students who have been marked absent. This could improve communication and allow students to stay informed about their attendance status. It would also be beneficial to integrate the system with the university's learning management system or LMS. This would provide administrators and faculty with centralized access to attendance data and other academic information, making the system even more efficient. And we have training and orientation. Regular training and orientation sessions should be held for both faculty and students. These sessions will ensure that everyone is comfortable using the system and is able to troubleshoot any minor issues on their own. A well-trained user base will lead to smoother operations and a better overall experience. We have maintenance and technical support. Establishing a dedicated technical support team is vital. This will ensure that any system downtimes or RFID tag release issues are addressed promptly. Having reliable support can help reduce disruptions and keep the system running smoothly without significant interruptions. That concludes the final chapter of our study. Thank you for your attention throughout the presentation. I hope this research has provided insights into how RFID technology can enhance the attendance monitoring process. Thank you for watching!